Okay, so now to show off the final part of our programming assignment 4, I'll be showing off how our implementation works on a little bit more complicated of a topology. So I guess just to start out, we can mess around with what we're sending. So maybe we'll just we'll send a message from host 1 to host 2, and we'll show that our routing tables are converging correctly, and that if we manipulate a couple important edge weights, we can alter the paths that things are getting sent on. So, well, I guess just to start, we can send this this message from host 1 and see where we end up. We're going from host 1 to router A, from router A to router C, so we're taking this bottom path, and then from router C on to router D, yep, and then finally from router D we're forwarding to H2, host 2, and then we successfully get our packet. So now if we just make this weight more expensive to get into router C, so we add it all the way up to 5, and we'll get our routing tables. And this is a simplified variation of the routing tables. Since we're not super worried about the pretty print for this iteration, for this version of the problem, and since we've already successfully implemented that and we know that that algorithm works right, we're just printing out the row for every corresponding router that we're looking at, instead of trying to print out the whole thing. It just got really messy with dealing with a whole list of dictionaries rather than only one dictionary in the two-dimensional case. So yeah, so anywhere that we have a value of 0 for the distance, that's the representative routing table for that particular node. So this is the routing table for router A. Here are all the final best distances to everything else. Here are all the best distances to everything else for router B, and so on for router C and router D. So now let's look, since we've upped the price to go through router C, we should have hopefully chosen router B. Let's find out. So yep, we go from H1 to RA, from router A to router B. Yep, so we did it right. And then router B to router D, and router D to H2, and then we get our message. So now finally, I'll leave you with us sending the message in both directions, one from H1 and one from H2, and they should each take different paths. And this should illustrate that we've computed all of these routing tables effectively, and that we indeed have implemented fully this more complex topology. So let's take a look. So we have a message from H1, and then our message from H2 is I hear you loud and clear, baby, the same one as before. So we're sending from H2 to RD, from H1 to RA. That's kind of just intuitive. And then from RB to let's see, so from RD to RB. So that's our message from H2 is taking this top path. So then hopefully H1 should be taking this bottom path. And indeed, our message from H1 that was at RA is going through RC. So indeed, we've chosen that lower path for that message from H1. And now following everything through, now it's not really much of a choice. Now it's just kind of which option, is the only one left to get to the final destination that we're shooting for. So for this message from H1, we need to go into RD. Yep, and indeed we do that here. And for this message, I hear you loud and clear, baby, that came from H2, we need to send that into RA, which we're also doing. And then finally, we forward these each to the hosts. So H1 should receive, I hear you loud and clear, baby. And H2 should receive this original message from H1.